Okay, sharing my screen. All right. Okay. Yeah, so to everyone who is not here for Computer Science 2A class, please exit the venue. Okay, so welcome to class, and apologies for starting a bit late. So hopefully we'll be able to get as far as possible with the lecture. Yes. Oh yes, the attendance code is right here. So if you're on campus, this is your attendance code. If you're online, I already posted the attendance code on Blackboard. So please just write this down, type it in your phone, type it in your laptop, and you can fill it in as we continue with the lecture. Okay, so I'm just going to wait for 1 more minute, and I'm going to remove the code from the screen. All right. Okay. So we finished the section on design patterns on Monday morning, and on Tuesday we did an example of applying the visitor design pattern to a problem. Right. So we did that in the practical lecture. So today we will not be doing design patterns anymore, but we'll be starting with the new section of the work, which is multi-threading. So just to give you guys a background, multi-threading is essentially a feature in many programming languages, including Java, that is based on running concurrent instructions at the same time, right? So the whole idea behind multi-threading is that instead of sequential programming, where you write instructions and the compiler executes the instructions right after the other in sequential order. In multi-threading, the compiler does not have to wait for the first instruction to finish executing before executing the next instruction. So it is used to achieve concurrent programming, and we'll look at how exactly that happens under the hood as well. So we'll be looking at multi-threading. We'll look at the thread class in Java, and we'll look at thread pools. Okay, so also before I continue, if you need to apply for the SIG test and you missed the deadline, please note that we have extended that until Friday. So tomorrow to apply for the SIG test, you must use that was used for the first semester test. So semester test 1, the Google form, that is what you use to apply for semester test 2 SIG test as well. So just keep that in mind. Okay, so multi-threading. Okay, so basically in multi-threading we have 2 main entities. So we have something that's called a task, and we have something that is called a thread, right? So a thread runs a task, right? So a task is basically a program unit that is executed independently of other parts of the program. So what that means is, in order for a task to run, there is no sequence of instructions or any particular instructions that needs to finish first in order for a task to run. It can run concurrently with other tasks, or rather with other code while your program is executing. And a task is usually wrapped around inside of a thread. So a thread is something that is also called a sub-process. You learn about that in 3rd year when you do operating systems. But this just covers threads at a very high level, right? From a programming language perspective. But the main idea that you should take from this is that in Java, you can create threads, right? And a thread is the mechanism for running a task, and it can also be defined as the flow of execution from beginning to end of a task in a program, right? So that is basically a container of a thread. You can think of it, or rather of a task, right? So you can think of a thread as something that contains a task and runs the task from beginning to end. Okay, so let's look at how you have been designing programs up to this point, right? So ever since from first year in Computer Science 1A, 1B, and Computer Science 2A, you have been designing what is called sequential programs, right? So you've basically been, for example, having a main method where you have these instructions and one instruction is executed after the other, right? So for example, here we have an example that's called do something, and then when do something is finished, then you do something else. When do something else finishes, then you do something different, right? And then that's the end of the program. So this is a sequential execution of instructions. But in multi-threading, you have something like this. So you have the start of the program, but you can do something else, and do something different all at the same time, right? So I hope that's not difficult to imagine because you can do it in Java, right? So this is called concurrent programming, right? What it means is if your computer, for example, has more than one CPU cores, you can write a program in such a way that you have different threads that execute on different CPUs all at the same time. And that's the main idea behind multi-threading. Okay, so let's look at these previous instructions more closely, right? So you have do something else, and do something different. And they must be done for the entirety of the program to successfully complete its operations, right? So this is sequential, as I mentioned, but there are cases in programming where you have instructions that do not have to execute in order, right? So they don't have to happen sequentially. So an example of this is a mail client, right? Let's say, for example, you're in Gmail and you're trying to send an email. And you send an email to one person, and you remember that, oh, I actually wanted to send an email to someone else, right? So imagine if you wanted to send an email to 1,000 different people at the same time, right? And let's say Gmail, or rather in programming, we did not have such a thing as multi-threading. Then what would happen would be the second email would only be sent after the first email was sent, and the third email would only be sent after the second email was sent, and so forth. You guys get the logic. But if you have multi-threading, what it means is you can tell your mail client to send this bulk email, and it would literally create different threads which are responsible for sending the email to different people, and one email would not have to wait for the other one to finish sending in order for it to be sent, right? Does that make sense? So that's the whole idea behind multi-threading, right? Where you have tasks that do not need to be performed one after the other. Okay, so as I mentioned, multi-threading allows for multiple threads to be run, which means that multiple tasks can be performed concurrently. So let's look at a bit of the lower level parts of a computer, right? So let's look at the CPU. So the central processing unit processes threads in order to complete tasks. And the number of processors or processing cores affect how threads are going to be executed in your computer, right? So this means multi-threaded programs run differently on different computers, right? So for example, if there are more processors than threads, then all the threads can be run simultaneously, right? So if you have 2 threads and 4 processors, then obviously those threads will all have processors to run on, and they will run simultaneously. But if you have one processor and two threads, you will wind up being in a situation where you have to schedule the threads. So that's also a topic you'll go into depth on when you do Computer Science 3B. But the whole idea is that if, for example, you have a CPU and you have many threads, then the CPU tries to schedule the threads so that it seems like it's concurrent, but it's not really concurrent. Yeah. So if there are less processors than thread, then each thread is run by sharing access to the CPU, right? So this is the whole idea of scheduling, right? So the CPU will allocate each thread an amount of time in order to run, and it will substitute it out, put in another thread, substitute that out, put in the other one, and keep doing that until both threads are done executing. So in Java, for a task to be runnable as a thread, it needs to implement this interface. It's called the runnable interface, right? So if you want to create a task, you must make sure that it implements the runnable interface. So let's look at a code example. So we're creating a class and we're calling it task. So you can call this class anything, right? So task does not have to be the name of the class. But in this case, for the sake of an example, we'll call it task. So task implements runnable, and we have a constructor where we basically have our constructor logic. If, for example, our task class has a state that it needs to maintain or something like that, then this is where we're going to initialize all of our variables. And then we have the most important method, which must be implemented by every class that implements the runnable interface. And that is called the run method. And this method contains the logic that needs to be executed when the task is started. So in this case, a task is only started by a thread, right? So only a thread can start a task. So if you have a task on its own, you can't really start it concurrently without encapsulating the task inside of the thread object, right? So you have to encapsulate a task into a thread. So this is the client that tries to run the thread. So we have a public class called client, and we have a method that's called do some work, and we have an instance of the task, and we have a thread that we have to execute our task, and we instantiate the thread, and we put the task into the thread, right? So as I mentioned, only a thread can start a task, so we need to place the task inside of the thread. And then we start the thread by, or rather we start the task by telling the thread to start the task, right? So what this means is that when we call thread.start, then the start method of the thread will then cause the run method of the task to execute. Does that make sense? The only difference is that the run method of the task will be executed concurrently. Right? Do you guys understand? Are you still following? Okay. So in this example, so let's say, for example, we have two different types of thread, and we implement the runnable interface. So we have a method called print_char, which prints a specified character to the console a specified number of times, right? So this is very simple. We print a specified character, specified number of times. There's nothing new in that, right? This is what we've been doing all along. And then we have another task, which is called print_num, which prints a number to the console a specified number of times. So in this example, the only difference is we want to execute these two operations at the same time. So we don't want to print the number, you know, like if we wanted to print it 10 times, we don't want it to print 10 times, then we print a character 10 times. we want to print both the number and the characters at the same time, right? So this is going to be a very interesting output. So, so let's look at the print character class, right? So what we have here is the print char, which implements runnable, and this is the character we want to print, and this is the number of times we want to print the character. And then this is the constructor. So in the constructor, we take the character and we take the number of times we want to print the character. And then in the run method, we basically have a for loop, also nothing new, what we've always had ever since this point. So in this case, we're just printing out the character. And then this is the class for printing the number. So we have the same thing, we have the constructor, and we have the number of times we want to print the number. And in the run method, we have similar code to the print char class, which basically has a for loop and prints the number that number of times. So now let's see how this would be accomplished in the main class. So in main, we have our main class, we have our main method, and we have our basic function signature, and we create our tasks. So I create the print char task, and I'm going to print the letter A 10,000 times, print B 10,000 times, and print the number 1 10,000 times, right? And then what I do is I create a thread for printing A. Remember, a thread contains a task, right? So I have to create a thread for every task. Does that make sense? So I provide the task to the thread, provide the task to the thread, provide the task to the thread, and then I just start the threads, right? So if you're looking at it in terms of like in text, in a text editor, it looks like you are executing these things sequentially, right? But the trick here is that when the compiler looks at this, it will execute this, and when it gets to this, it will not wait for this to finish executing. It will just start executing this as well, and it will not wait for that to stop executing. It will just start executing that as well. So it will be a big mess of tasks that are just all executing at the same time, right? So because of time, I was actually going to do this with you guys in class, but we can't do it in the next lecture. Oh yeah, tomorrow is a tutorial, so we'll do it tomorrow morning. But before then, I want you guys to compile this code. So I promise you, you won't find any errors, but don't try to copy and paste. Try to do it on your own, right? And see what the output will be. And then we can do it together tomorrow morning, and we will analyze what's actually happening in a more deeper level. Okay, so yeah, so I'll stop here because we are clearly having problems today, but thank you very much and enjoy your evening, and I'll see you guys tomorrow morning.